Okay, so this lecture is on solving exponential equations. So let's solve for x, and whenever we need to approximate it with a calculator, we'll round our answers to 4 decimal places. So our first example, we have 4 to the x is equal to 3. Now we're trying to solve for x, right? Now if this was x to the 4th, what would we do to solve for x? We would take the 4th root of both sides, right? That's not what we have here. We have 4 to the x is equal to 3. So we have to essentially do the opposite action of 4 to the x. We need to apply the inverse function to both sides of this in order to get x out. And what's the inverse of 4 to the x? Well, that would be log base 4 of both sides. So I'm going to take log base 4 of the left side and log base 4 of the right side. So log base 4 of the left side, because it's log base 4 of 4 to the x, I'm going to just get x back. And then my answer is log base 4 of 3. And if you wanted to approximate this using your calculator, what would we get? Well, a lot of calculators don't have a generic base for your log. They don't have a way to input this base here. But we have this property, if you remember, that if you have log base b of some expression, right, we can rewrite that as log of any base you want. So for example, I could use the common log, base 10, or I could use natural log, and your calculator does have those two. So I could do log of x and then divide by log of b. Okay, so this is one way to convert this expression. So if you wanted to use your calculator to approximate this, you would probably do log of 3 and then divide by log of the base of 4. And so this is actually equal, but you could then solve this in your calculator and get the approximate answer, which would be 0.7925. All right, now our next one, we have 3 to the x is equal to 4. So to do the opposite action of 3 to the x, I'm going to take log base 3 of both sides. So take log base 3 of the left equals log base 3 of the right. And so these two are inverses, so I'm going to get x is log base 3 of 4. And how would you punch this into your calculator? Well, you could do log of 4 divided by log of 3. Okay, and you can get the approximation. Now, if your calculator, if you prefer to use the natural log, that is fine as well. This is actually, you're allowed to do this with any base. So just so you know, you could figure it out that way and get the same answer, even though that the common log, base 10, and natural log are not the same, but those two quotients actually turn out to be the same no matter what base you pick, as long as the bases are consistent. So you would use a calculator to get an approximation for this, and it looks like it should be 1.2619. Okay, so moving on, our next one is 8 to the negative x is equal to 7. Well, in order to find the inverse function, I'm still going to apply a log base 8 of both sides. Okay, and these are inverses, so I'm going to get the exponent of negative x, and it's equal to this. So then that means x is the negative of this, so negative of this answer. And if you wanted to figure this out using your calculator, you would probably type in this, negative log 7 over log 8, the base here. And this will be approximately negative 0.9358. Our next example is 9 to the x plus 1 is equal to 3, so we'll take log base 9 of both sides. And this gives us x plus 1 on the left is log base 9 of 3. So then subtracting 1, we have x is equal to log base 9 of 3 minus 1. And so you would write this as log of 3 over log of 9. I would figure out what that is first and then subtract the 1. So this will be, after simplifying, actually, you know what? This will actually be pretty quick. You could use a calculator to get through the answer here. This is going to be exactly equal to negative 1/2. Sorry. How would you do this without a calculator? So if you wanted to use your calculator, you could substitute that in and get this. How do you get this without a calculator? Notice log base 9 of 3 is actually log base 9 of 3 is actually the square root of 9, right? And then you have 9 to the 1/2, right? And so then these would cancel and give you a half. So you'd actually have a half minus 1, which would give you negative a half. So that's how you could do it without a calculator. But if you don't notice that, that's fine. You can just use your calculator. You'll get the same answer. Perfectly fine. All right, not our last example, but example 5 here. We have 2 to the 1 minus 2x equals 3, so we'll do log base 2 of 2 to the 1 minus 2x is equal to log base 2 of 3. These will cancel, and we'll have 1 minus 2x, just the exponent there, is log base 2 of 3. Okay, so now we're trying to solve for x, right? So let's bring the 2x over here and subtract the log over here. So we'll subtract these, and we'll add the 2x over here, and now we'll divide by 2. And so x, this x, right, these cancel, and then I'm just left with this expression. So 1 minus log base 2 of 3 over 2. All right, now there's a couple ways you can plug that into the calculator. Right, we could write this as log of 3 over log of 2 divided by 2, and then you could figure out what this is, and then do 1 minus that, and then divide by 2. Just make sure, if you wanted to type all that in, you have to be very careful. You'd have to put parentheses around the whole numerator and make sure that you don't make a mistake. So it might be a good idea to simplify what that log is first, and then slowly simplify this thing. After doing this, we should get approximately negative 0.2925. And then finally we have this one here, so we'll take log base 7 of both sides. And we have 4x plus 3 on this side is log base 7 of 200. And then we will subtract the 3 over to get log base 7 of 200 minus 3, and then divide both sides by 4. So we will get x is equal to log of 200 divided by log of 7, right, the base, minus 3 over 4, and then this will approximately be negative 0.0693.